So this was a concepts assessment pop quiz which was related to topic projectile. You have any doubt in question 1? Question 1. Question 2. Any part of a question 2? Question 3. Any doubt? Question 3 and question 4. Any doubt in this? The last one is question 5. The question 1 to question 5. Any doubt? Last part. Which question? The last question? Okay. Last page. Okay. The initial velocity of a ball as it projected from a machine can be increased. Explain how increasing the initial velocity would affect the angle at which the ball hits the ground. Look, when we launch something horizontally, when an object is launched horizontally, the time it takes to reach the ground will not change because the vertical component remains the same. Because we are dropping from a certain height, h is there. So when this at the beginning, the vertical component is 0, but at this point, the vertical component will increase. It will have an acceleration, same as due to the gravity. Horizontal component is not changing, but the vertical component is increasing. And v is the velocity at which it hits the ground. And this velocity will have the two components, the horizontal and the vertical. Now the question is, what will be the effect at an angle at which we increase, like if we increase the horizontal component? Vertical component does not change because the vertical component depends on the height from which it is being dropped. If the height remains the same, so vertical component does not change. Now, what about the horizontal component? If we launch at a greater, higher horizontal speed, then the value of the horizontal component will be greater. And the vertical component remains the same. And the velocity, like what will happen to the resultant velocity? If you are, this is an example representing the resultant velocity. And if you're taking the angle from horizontal, theta, and we are taking theta from horizontal. So if I'm taking theta from horizontal, this will be Vy. So I can use a trigonometric ratio tangent theta because I have the perpendicular and the base. So tangent theta is perpendicular, like the vertical velocity divided by horizontal velocity. Now, this is not changing. And the horizontal velocity is increasing. If the horizontal velocity is increasing, so what will happen to the value of a tangent theta? The value of the tangent theta will decrease. And if the value of a tangent theta will decrease, what will happen to the theta? The theta will also decrease. So if we are taking the angle from the horizontal, if we are taking angle from the horizontal with two different horizontal velocities and the vertical velocity does not change, so what will be the resultant velocity here? Like red is representing resultant velocity. So this will be the resultant velocity. And what is the resultant velocity? This is the resultant velocity. So you can clearly see that when we increase the angle, when we increase the horizontal component, the angle from a horizontal will decrease. Because the horizontal component is increasing, so value of a tangent theta will decrease. And when the value of a tangent theta decrease, the value of the theta also decreases. So when you mention this answer, first point you will mention the horizontal component will increase, you will score 1 mark. The vertical component remains same, you will score another mark. And mentioning the horizontal component increases and the vertical remains same, so the angle with the horizontal will decrease or angle with the vertical will increase. Like if I'm talking about the angle with vertical, when I talk about angle with vertical, this angle will increase, but angle with horizontal will decrease. So this was a pop quiz, the structure pop quiz. Any question or doubt related to the session today? As we discuss the work, energy, and power.